guys, so this is the first video and we're going to look at some basic electronics. That's it, just a recap of what we saw in the first video. So, alright, here is that 3-volt battery that we talked about in the intro, and we also have the LED. And the only thing we're going to do different this time is that we're actually going to use these guys over here, which are called jumper cables, to get electricity to and from our different components. Alright, so the first thing we're going to do is we're going to use power from a battery that we can actually hook up to our board using this barrel jack connector that's on it. As I mentioned in the intro, an Arduino can receive power through its barrel jack, and that's exactly what we're going to do now. This is the barrel jack right here. Okay, so the first thing we're going to do is, as I mentioned, we are going to look at what kind of voltage are we dealing with around here. So we need to have an idea of the values, the magnitude of what we're talking about. So I have here my multimeter, and we're going to measure the power from the battery and get an idea as to the voltage. So let me get this lead here, and I'm going to test the voltage with my multimeter. So, oh, wait a minute. Well, the terminals are actually the other way around. That's why we're getting that negative sign on there. So let me flip those, and let me get these in here. There we go. All right, so it's around 8.2, 8.3 volts. That's what we're talking about. So, well, the variation is because I'm not holding it tight enough, so they keep slipping on me. Let me try to get this a little bit better. And there we go. All right. So 8.32 volts. All right. So it's not a fully charged 9-volt battery, but it's still pretty decent. When we take our Arduino and we plug in our 9-volt battery, as we mentioned in the intro, we are going to get power coming out of the different ports, and it depends how much power or what ports will actually give out power depends on the chip that we talked about. So if we look at this a little bit closer, I'll try to bring this up. As you can see on this bottom row, we have a couple of pins that are labeled 5 volts and 3 volts. That means that those two pins will actually put out 5 volts if there is enough voltage coming into the barrel jack. And you have a couple of grounds on this side, and you also have a ground on this other side as well. The pins labeled 0 all the way up to 13, and these analog pins labeled A0 through A5 will only put out power in the way that the microcontroller actually allows it. So let's just test this out. We've got our indicator LEDs on. So this is just a power LED on the right side, and we've got our LED 13. The LED 13 is an onboard LED, which is actually connected to pin 13, and whenever pin 13 is high, it actually turns on. So all that's saying is that we actually have pin 13 on high. So how are we going to test this? Let's plug in ground cable right in here, and our 5 volt is right here. Okay, so let me actually bring this up for you guys again. So as you can see, we've got one cable connected to the first ground on the right side, then there's an empty pin with another ground, and then there is the 5 volt. So let's make sure that this is true. I'm going to take my multimeter again, and I'm actually going to connect this ground to one of the leads. I'm going to struggle a little bit here to actually get this cable to stay. And then I'm going to plug this into the other lead. As you can see on the multimeter, we are getting 502, which is pretty close. Now let's move this over to the 3.3 volt. And there it is, 3.34 volts. All right, if we plug this cable into one of the analog pins, we get 0 because that pin is set to 0 by default, set to low. Any of the digital pins also set to low by default. And if we move over to our pin 13, which was on high, it actually went a little bit low. It's now down to 13. All right, and there it is, back on again. Okay, so now we have an idea of the voltage that we're talking about. So this is whatever we put in, and there is a limit as to how much voltage we can put in, or we will actually fry our board. Will get sent out as high as 5 volts on all the pins whenever we want that to happen. And we'll see how to do that when we get to the coding part, probably in the next video. Right now, the only thing I want to do is give you a few examples of some basic things we can do. So let's give it a try. As we said before, we've got ground. We're going to connect it to this rail here, which is negative. All right, and so the way this works is on these breadboards, this whole long side row or column, depending on how you want to refer to it, is positive. Well, it isn't positive, but it is whatever you connect to it. So anything that I connect on this pin here is the same I'm going to get here, same I'm going to get here, 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 all the way along this row. So right now, this entire row on the blue side is 0, reference, ground. And when I plug in the positive cable to the red row, I'm going to get 5 volts on this entire row. And the way you do this is you bring 5 volts positive and ground negative to your components on these rows right here. Now, everything on one single row, every pin on one single row is connected. And these are numbered 1 all the way down to 30 on this particular breadboard. And if we take number 14 here, this pin 14 is connected to this pin 14, and this one, and this one, and this one. So you have letters up here denoting the columns. So A, 14 is connected to B, 14 is connected to C, 14, all the 14s are connected. So what we're doing here is we're taking ground, connecting it to the negative rail, connecting it to this resistor just to hold down the voltage a little, the current a little bit, because we don't want too much current to flow through this lead or we'll burn it. It's the only thing this component is doing right here. So 0 volts going through this rail into the resistor, and from the resistor, which is actually on row 25, column C, as in cat, everything that's 25, C25, is also connected to D25, as in David. So the lead, one of the legs of the lead, is connected to D25. That means that the resistor is connected to the lead. The other leg of the lead is connected to D27. And D27 is what we need to connect to our 5 volts. So what we're going to do is we're going to take this 5 volts and we're going to plug it into A27. Okay, and the way this is hooked up is actually the longer lead is the other way around. So some components you have to worry about polarity. So in this case, there we go. All right, so just to recap, the resistor leg is on C25, Charlie 25. The lead leg is on David 25. That means that the resistor and one of the legs of the leads is connected. The other leg of the lead is on David 27, and the 5 volts is on alpha 27. So that means that one of the other leg of the lead is connected to the 5 volts. So one leg positive, the other leg negative via a resistor to the ground rail. So the lead lights up. Okay, now let's unplug this, and to keep things a little bit more ordered, let's make sure that we plug positive into there, and we're actually going to use a cable, or a jumper cable, in the same way that we use the resistor to come over to our component. And you're going to see it's going to do exactly the same thing. The lead is going to light up. So all we're doing is bringing current from the plus and the negative rail in an orderly fashion over to our component rows and columns. Okay, so what we're doing is we're taking the current that runs out of this 5 volt pin and running it to our lead, much in the same way we were running 3 volts to our lead in the intro. The only difference with the other pins is that those other pins will only put out 5 volts when the chip is programmed to do so. Okay, so we've got a lead. That's pretty cool. All right, let me get this out of the way. Let's look at something else. Let's plug in a motor. Same thing, same concept. The current is going to go in into one terminal and go out the other. And this is going to be a little bit harder for you guys to see, so let me actually plug this in the other direction, and I'll try to work the cables somehow. Okay, so you can see, and all the motor's going to do is vibrate a little because there's really not much else we can make it do. We can make it turn a wheel if we connect a wheel to it. Okay, so I'm just replacing where the lead's legs were with my motor leads. There's the plus one and here's the negative one. Okay, and as you can see, the motor isn't doing anything. So what happened? Did something stop working? Not really. If we plug this back in, wait, did I plug this in the right way? If we plug this back in, take the motor out of the circuit, it works just fine. So what's going on? Well, the current that runs through this circuit from the 5 volt pin to this cable, in through the red cable of the motor, out the black cable of the motor, back to the resistor, to the rail, through the ground cable, back into the Arduino, is simply not enough to run a motor. It is enough to light a LED, but it is not enough current to light a motor. So, simple. Currently, the circuit has been broken, and all we're going to do is complete the circuit without the resistor. The resistor was holding back some current. Now, it is not holding back any current, and you can hear the hum of the motor actually running. All right, so that's pretty cool. So we've run 2 components so far, and we've learned a little bit about current. When the component requires very little current, we need resistors, and we're going to use these guys a lot. When something such as a motor, which requires a lot of current, is connected to the circuit, we cannot reduce the current running through. We need more juice. All right, that's the way to change the amount of current running through something. Let's take a peek into changing the amount of voltage, and that's what this guy does. So this is a potentiometer, or a pot for short. It's got 3 leads, and one of them is for the negative, the other one is for the positive, and the middle one is what's called the wiper. The wiper moves left to right, much in the same way as a wiper in a car. I'm going to connect this middle one to pin 15, which means that 14 has the positive and 16 has the negative. All right. So all I've done so far is I've taken the 5 volts coming through here into the far side of the pot, and the 0 volts in here through the other far side of the pot. What I need now is the middle pin. The middle pin is what's going to take current, or voltage actually, and move it around. Okay, so we're going to take that voltage and we're going to output it over here on E1. And we're going to do the same setup. So we had the lead like so. And we're going to protect it with our resistor like so. Because remember, we said resistors only limit current. They do not limit voltage. Okay. So what we're doing now is we can change the voltage that is going out of that signal through this lead and back to ground. And there it is. So when the pot is turned completely counterclockwise, we get the full 5 volts. When we turn it in the other direction, the light dims until it turns off, which means that the signal is at 0 volts. How can we test that? Simple. Take this, connect it to our signal lead, and we take this guy and connect it to our ground. Now what this means is that anything that's going through that pot is going to be going through our multimeter. And as I move this pot counterclockwise, you can see the voltage rising. 1.3, 1.5. The light is still off, but the reason the light is off is because I don't have a signal cable connected to it. Give me a second here. Just realized that. Now, working with breadboards can get a little tricky because things can get a little cramped really quick. Okay, let's take this back down to 0. Okay, so there it is at 0, and the LED is off. As I start turning counterclockwise, voltage goes up, and the LED is still off. When we reach 1.5 volts, around 1.6, the LED starts to glow. And as we get more and more, as we get closer to the 5 volts, the LED becomes brighter and brighter and brighter until we're at our max, 502, which was what we measured coming out of this pin in the beginning. So there you have it. That's what a pot does. It controls voltage. A resistor controls the amount of current. And now we know how to mess around with jumper cables, and we know how to use a breadboard, and we know about the magnitude of the voltages that we are dealing with when we're dealing with this microcontroller Arduino. And different microcontrollers operate at different voltages. This is just what the Arduino and many of the other ones are used to working on. So the last thing I wanted to do, we would actually need to connect this microcontroller to the computer program. What we're going to do is we're going to use one last component, which is this guy right here, to do something a little bit more significant. This is a DHT11, temperature and humidity sensor. 4 pins, one of them is actually NC, N as in Nancy, C as in Charlie, not connected to anything. The other ones are the 3 signals, or the 3 pins, which are very common in most of these microelectronic components. One is 5 volts in, or VCC, because which is just voltage. Some components work on 5 volts, like this one. Other components, as we'll see later, work on 3.3, which is a very common voltage, like the one we saw off of one of the pins in the Arduino. And the other one is ground. So we've got VCC on one side, ground on the other, and the third pin, is the signal pin. Now, what that does is that signal pin, this is pretty much a sophisticated version of our pot. As I mentioned, let me try to get this into focus here. As I mentioned, the 4th pin on this DHT11 is empty. It's not connected to anything. So there's actually 3 pins on here, just as in the pot. As we turn the dial on this pot, we are working from the 5 volt range all the way to the 0 volt range. In this guy, we are giving it the same reference, 5 volts and 0 volts. And it is going to put out a signal in the middle, much in the same way that the pot puts out the signal, except that in this case, we're controlling that signal voltage with the dial as we're turning it. In this case, and the case of many other sensors, that signal output actually depends on what's going on inside the sensor. And most sensors work in this way. This is a sensor, a resistive sensor, which basically means that whatever is going on inside, which is dependent on what you are measuring, in this case temperature and humidity, will directly affect the voltage that's coming out of that 3rd pin. And that is actually how we get a signal from a sensor into a microcontroller and then turn it into something useful. So in this case, we're going to measure whatever's coming out here, and we're going to use that data. I'm going to plug this into pin 10, which means this goes all the way to pin 13 because it's got 4 connectors. And we're going to use that and try to get this in. This is sometimes tricky, and you don't want to be too rough on your pins, or you might actually break one of them off. Sometimes you got to wiggle these things to get them to go in. There we go. Okay, so we've got, just to make sure we don't want this connected to anything right now. So we've got 3 pins in here that we're going to work with. The signal pin, the 5 volt or VCC, and the ground. And we're going to look at how that works, how we find out what a sensor needs to be connected to, and how to actually get it onto the computer. So we're going to switch over to the computer right now, and we're going to look at the pinout, which is how to find out what these 4 pins are on any component, not just on this one. And then we're going to actually connect one of the third jumper cables. Use the yellow one. I like using yellow for signals, or blue. And we're going to use that third component, or that third pin, to get a signal out of it. And we're going to just connect these. Assume that these are connected. I know that we're not, because actually the last thing that I didn't tell you about breadboards is there is a division right down the middle here. And this means that all of these pins are completely isolated from these other pins. So even though this is aligned on this side, pin 10, with this side, pin 10, which is the first pin of our DHT, they're not really connected. And this pin over here, which is the positive, is on pin 14, but it's not really connected to this. Actually, it needs to be on pin 13, sorry, because we're starting on pin 10. So 10, 11, 12, 13. And then the middle, one of these middle ones, and we need to check in the pinout, that's what the pinout reference is for, is going to be our signal. So this is going to be like the middle pin, the wiper pin on the pot. And whatever we get here is a voltage, the same way that what we got from this wiper pin was a voltage. And we need to convert that voltage into temperature and into humidity. And we're going to look at how that works on the computer, on the program, and we're going to actually look at what that data looks like in the software, in this programming software. And then we'll do that to sort of give an intro to the Arduino IDE software. All right, so we're going to leave it here for now. Hope you enjoyed the video, and the next few videos we're going to cover some of the other basics, and then we're going to straight jump into products. I want to start showing you how easy it is to build products, because when you find a product that you are interested in, that's what's going to get you really pumped about this stuff, and it's going to make you go through all the hoops that you need to go through, the learning curve, and all the the late nights looking up information and whatnot to actually build something that you're really interested in. Otherwise, if we just keep lighting up LEDs and running motors and stuff like that, you're going to get bored pretty quickly and bogged down with all the details, and I don't want to do that. So once we get done with this 101 basic introduction to microcontrollers, we're going to look at the software part really quick, and once we're done with that, we're just going to start picking up other components as we go, and we're going to start building products that are actually important, meaningful, and can actually be worth something. All right, so I'll see you guys in the next part.